Okie dokie. In this problem, they say when this rational function is completely reduced, what is the degree of the polynomial in the denominator? What they're expecting you to do is to factor expressions like this and cancel terms out on top and bottom if there are any terms that can cancel on top and bottom. So we are reducing this quotient or this rational function and seeing what we're left with in the denominator. What's the highest exponent we are left with in the denominator. So let's start by factoring the numerator. I'm going to kind of ignore these numbers here, and our main focus is just to factor this here. So factoring x squared minus 2x plus 1 into two factors. We have x, We're looking for two numbers that multiply to 1, which can only be 1 and 1. And those two numbers must also add to -2. So that means 1 and 1 should be negative, because -1 plus -1 equals -2, but -1 times -1 is +1. Okay, so that's our numerator. Now we're dealing with the denominator. Well, we really don't have to do anything. We just rewrite it, right? And what you'll notice is we have x minus 1 on top, canceling with one of the x minus 1s on the bottom, but we also have a second x minus 1 on top. So really, we have two x minus 1s on top and two x minus 1s on the bottom, because we have x minus 1 squared. So we can get rid of both of those. And what we are left with on the bottom is x plus 2 squared. So the degree of that polynomial corresponds to the exponent that is remaining there. Because if we expanded this, we'd have some x squared plus, 4x plus 4, whatever. It doesn't matter what that is. It's really, again, just the exponent is what you want to focus on. So x squared is the degree of the polynomial in the denominator, because it's the highest exponent that remains in the denominator. And that's all there is to it. Let's do a couple more. Again, up top, or I guess, again, we can ignore those numbers out in front. They do not affect the, the process of this problem. We want to factor the numerator here. Go ahead and put x here. We need two numbers multiplying to -12. Think about numbers that multiply to -12 that might also add to +4. So try out numbers that can multiply to 12 first, and then kind of mentally test, do they add to 4? So for example, 4 and 3. 4 and 3 multiply to 12, or say -4 and +3, or -3 +4, however you want to do it. But then ask yourself, does 4 plus 3, or -4 plus 3, or -3 plus 4, whatever, add to 4? Or could it add to +4 in any way? And then hopefully you would say, no, it does not. So let's try another combo, 2 and 6. Could any combination of like a +2, -6, or vice versa add to +4? Hopefully then you would say yes, because a +6 and a -2 multiply to -12, but add to +4. So we get those values, and then on the bottom, we have x minus 2 squared and x plus 2 squared. Does anything cancel on top and bottom? We have an x minus 2 canceling with a single x minus 2 on the bottom, making this exponent now just a 1, basically. So what we're left with is x minus 2 to the first, and then this is fully gone, right? And they want to know what's the degree of the polynomial in the denominator. So you want to imagine if we multiplied these two terms out, if we multiplied everything out, we'd have an x to the first being multiplied by an x squared from this factor here. X to the first times x squared is x cubed. So the overall highest exponent in the denominator would be 3. So that is the degree of the polynomial in the denominator. All right, let's do one more. Rational function, blah, 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 blah. Okay, let's not focus on the 2 there. And this one's a little different. We can't factor this. We could factor this right away if you wanted, but I might recommend if all of these are negative, let's go ahead and pull out a negative. Really, if just the x squared is negative, go ahead and factor out a negative. So factoring out a negative on top leaves us with positive x squared plus 7x plus 10. It's very important to factor that out, because it'll make it a lot easier on you. So then, kind of like the other numbers that were in front of the numerator, in the other problems, we can eliminate that negative. Just don't worry about the negative, because now we're just factoring the numerator. Factoring this expression here, we need two numbers that multiply to 10 but add to 7. So 5 and 2 come to mind. Just 5 times 2 equals 10. And they naturally add to 7. So that's beautiful. Now, on the bottom, we bring down the denominator terms here. X minus 4 squared and x plus 4 squared. Does anything cancel on top and bottom? No, we have no factors that are identical on top and bottom, so nothing can cancel. So what does that mean? They're asking still, what's the degree of the polynomial in the denominator? So if we multiplied this out, what would our exponent be? What would our highest x exponent be? Well, this would give us an x squared once we expanded that, and this would give us an x squared. So if we multiply those two together, we are getting x to the 4th. And that's it. So here was a nice, variety of problems you would see for this one. I hope this makes sense. I hope this sheds some light. If you get some other weird examples that I did not cover, feel free to send them my way if they are still giving you trouble, but hopefully these examples will help you approach those other weird ones. If you have questions, though, let me know.